David.
Okay. Solution for task 1. So GPA's credit hours times points divided by total credit hours. The first thing is to find Isabella's GPA. So we did it on the board. You can just use that equation. Then the second thing is Isabella's 20 other friends also want their GPA. So this table shows the credit hours times points, which is a numerator, total number of credit hours as a denominator. So I put this into Excel. And if you just click on the solutions at the top, you can just actually just see this as a solution. Can I zoom in? There you go. So if this column weren't here, this is how you make it. You type in GPA and then you press equals and you press this first one as a numerator. Then use the dividing symbol, this one. Whoa. Wow. So yeah, this dividing symbol right here. And then I have to click on the next thing, which is the second cell. Press enter, and then I have the GPA of the first person. And then you click and drag this box in the bottom right corner and drag it all the way down for all the rest of the students. Okay, task 2. Wow, task 2. Okay, so it says an inventory of machine parts. There's a lot of tasks here. The first one says you need to determine the greatest number of units among all of the parts stocked in the inventory. So you use the max function. So I put it in the solutions here in task 2. You can look at the tabs on the bottom right here on the solutions page. I labeled task 1, task 2. Okay, so I copied it and pasted it. And the greatest stock is 95. So I use this equals max B2 to B13 in my case. And I press enter and it gives me 95. The next task is to find the average stock. So it's the average of all these numbers right here. So you can use the average function. So equals average, and then you select these cells and it gives you the average of these cells. Next one is sum. So the total manufacturing cost and inventory. We have manufacturing cost. I use the sum function, SUM, and I select these cells. So that gives me this $28.88. Average manufacturing cost. I use the average function of the manufacturing costs. So average equals these cells again. And then last one, she needs to determine how many parts have a unit price that is greater than $2. Okay, so unit prices are here. How many have a price greater than $2? You can use a COUNTIF function. So you type in COUNTIF and then you just select these ones. The COUNTIF also requires a second argument, which is like how it works. Because I selected the cells, but it doesn't know what to do with it. This is what you need to write in. You need to write in quote greater than 2. So it's going to count everything if it's greater than 2. You press enter and then it gives me 6. So there are 6 items that cost more than $2 in this whole list that I fed into it. So COUNTIF 6. There's the last part, number 2. It says how to use the if function. I don't expect you to, I won't put this on the test because it's more complex. It's more related to coding. But this is how you would do the if function. It follows this form: if parentheses condition, then result if true, and result if false. So it takes whatever that cell is. It has like the condition is either met or it's not met. So the way I wrote the if function here is if the cell is less than 30. So we're gonna talk about, what is it? Stock, the number of items there are. Okay, so if the stock, let's say number 10 items for this first one. If the stock is less than 30, then you return 100 minus that stock. So 100 minus 10 is 90. So it's going to return 90. Otherwise, return 0. 0 if you read the lab, it says if you don't have less than 30 items, then don't. If you have more than 30 items, if you have more than 30 items, don't worry about it. Like you have enough of the item. If you have less than 30, then you got to worry about it. You got to tell me how many items to order. So that's the difference between the true condition. I don't know if you can see that. The true condition, 100 minus B2, and then the false condition, 0. So I wrote that at the top here, and then I dragged it all the way down. Question? This one?
No, for the manufacturing or the sale point?
Count if?
No, I know, but you did it for the, okay, manufacturing cost, not the.
Yeah, I took these one right here.
Right.
Manufacturing
I
costs.
did it for sale.
Okay, any questions on task 2? Okay, task 3. So we have a bunch of data points here. I have to put in Excel, call this task. This is actually task 4. That's for later. Task 3. Okay, so 2.29, 2.76, 3.22, 1.85, 1.15, 2.14, 1.97, 2.68. All right, this says, what is the sample mean? So you can use average to get the mean. So I'm going to type in equals average and then put in these values. That might be hard to see for people. Here you go. Okay. Equals average is 2.25. Get the sample standard deviation. So I'm going to use stdev.p. P stands for population. So I would just type in stdev.p and then put in these cells. I get 0.5966. Anyone else get that?
I got 0.6.
So if you use normal stdev, stdev, not p, you will get 0.637. P stands for population. So in this course, it just depends on how you calculate it, but in the equation on this sheet right here, this is using the population version of the equation. So stdev.p. There's different types of standard deviations. Okay, the senior aerospace engineer decides to discard the sample set if the standard deviation is greater than 1. Does Isabella discard the sample set? No? Okay, so standard deviation is 0.6. Well, let's go with this one. 0.59. So it's less than 1, therefore does not discard. Okay, Isabella needs to make a histogram showing the amount of cracks there are. She uses Excel to make a histogram with 5 to 7 bins. To do that, I take the data set and I go, well, this is Google Sheets actually. So I'll show you the Google Sheets and then Excel version. Chart. And then there should be like a histogram option. I think this is already is there histogram? No, this one. There we go. And then you can say how many bins there are somewhere.
I think it's so much easier to do it on the phone. I think it's in series.
Sorry,
How come you got
that was the wrong size.
Like, how'd you get your average fire?
I actually don't know how to change the bin size in Google Sheets. I have to like dig around somewhere here. Really?
Yeah.
The average is right here. I use equals average.
But,
Yeah, you missed 1.45. Between 1.15 and 2.14, there should be a 1.45.
So I'm gonna insert a row and then 1.45.
It's like our numbers.
Okay. Thank you. In Excel, you just go here.
Does it matter? I mean, does the base matter?
Yeah, it's like how you display your information. So I have this in Excel. I'm going to insert a histogram. So I go insert and then histogram.
Like, does it matter how many?
It's specified in the requirement, how many. Like if I do 2 bins, it doesn't give me much information here, like how the distribution looks. So I right click this data point, format data series, and then bins, and the number of bins, I can say 5. So now it's clear that it's like kind of uniformly distributed. If I do even more bins, it's more specific. Like I spike here and here. Okay, so we did a histogram with 5 to 7 bins. She needs to explain to the aerospace engineer what the distribution looks like. So actually, let's say 7 bins. And can someone tell me what this distribution looks like?
Looks like it's going up and it stops and then it goes down.
Okay. So there it kind of like peaks up here in the middle. There's a missing part right here. Sometimes distributions look like a bell shape. So that's called a normal distribution where, yeah, a bell curve, it looks like a bell. There's a peak in the middle. The what's your question?
That's the standard deviation.
No, it's not shown here. No, well, you can plot standard deviation on this graph. Like there's an average, which is what you calculate.
You can base the standard deviation off that chart.
Maybe. I wouldn't go that far. It's fine. Okay, so that was task 3. Any questions on task 3? Okay, task 4. Isabella is working with her boss to do some tests on their new products. So she does a drop test on that new product, which she can't disclose. So it kind of increases over time. Like if you drop an object, it's going to go faster and faster over time because of the acceleration due to gravity. So we're going to graph this. We take the time and velocity and I put it in the solutions over here. Okay, so I did this thing. You can insert a graph in Google Sheets. So generally over time, the velocity increases like a line. If you do this in Excel, which is much better because I don't know how to modify that thing, I get this. And you have to display the equation of this. Well, you show the points on a scatter plot. You add a trend line, and then you can show the equation of that trend line and an R-squared value. All right, so here's how I replicate this graph. I take the points right here. I go insert, and where it's the same area where we made histograms, I just insert a scatter plot. So they're just going to be a bunch of dots. If you choose these other ones, they're not a good representation of the trends. These are like an artificial like line made by Excel. But we start with a scatter plot. I click it, and then it should show time on the bottom and velocity on the side, and it says like chart title. So you can change the chart title if you want. I'm gonna say velocity versus time. By the way, I just copied the lab. It said the time's on the x-axis and velocity is on the y-axis with this format. Okay, I can do add chart element. So you go chart design and then add chart element. It might look different on Microsoft, but you can add chart elements this way, or you can like right click this graph, play around with it. Like you can right click this area and it says like format axis or whatever you want. So then there's like options on the side. Don't know if you can add a title to it that way. It might just be here. So I do axis titles, primary horizontal, and then I can add axis title, primary vertical. So it's clear to me like what these numbers are. So time, I can write the units, seconds, and then on the side, velocity, then the units are meters per second. Is everyone okay so far on this? To add the trend line, I click on one of the dots. So I can right click one of the dots and it has this option called add trend line. Add trend line. And on the right side, there are different options for the type of trend line. So it's shoot, I wrote it in here. There's a term for what it's actually doing. Regression analysis. So it's doing a regression analysis.
For the best fit one.
Yeah. So you can choose linear because it's the best fit of this is a line, and since it's acceleration due to gravity, we want the slope of the velocity changes. So that is acceleration. Acceleration is change in velocity. I did linear, and then down here you can say display equation on chart and display R squared value on chart. It's on the side of this whole option thing, format trend line options. Good question. What's the acceleration due to gravity?
Oh, no.
Who knows it?
9.8 something.
1.
1.
9.81. Okay, what did I get? It looks like I got like 9.392. It's close. So that's how I know I'm right. It's the slope of this line. That's the acceleration.
Did you type that or did you get it to say that?
I just clicked right here. Like if you click on the thing, when you're making the trend line, you can choose to add the equation automatically and the R squared value. R squared value is like how far away your data point is from that line. So like this point is away from that line.
How active it is.
Yeah.
The closer you are to the end of that.
Yep. So I don't think I even talked about it in here, but there's like a context to what R squared value is. All right, so we did, what is Isabella's velocity versus time graph look like? We did find the acceleration of the object and the best fit line and the R squared value. The slope of the line is acceleration due to gravity. What did she get? We said it was 9.9392. How close was her value of acceleration due to gravity compared to the actual value of acceleration due to gravity? So we just take her value minus the actual, or vice versa, it doesn't matter, this top part, divided by the actual times 100%. So the actual is 9.81. I'll write it down here. Actual acceleration due to gravity, 9.81 meters per second squared. And at the bottom, there's just how to make that graph in Excel. So you can always go to this reference. You can tap insert, and then the whole graph stuff is over there, and you can read this.